All right, guys, for those of you who would like to go through some of these problems again or see some of these done from the kinetic and potential energy calculations, feel free to watch this. I have posted a key, and I'm going to let you guys focus on the key for this first page, but I will go through a few of these problems with you if you'd like to flip to the next page. As you can see, there were a few I exempted you from, but I would like for you guys to get in the habit of showing your work because for now, I'm not looking at your work. But if you do not show your work all the way and get the wrong answer, you cannot receive partial credit on your guys' assessments. So let's go ahead and start going through this. A roller coaster with the mass of 1,000 kilograms is at the top of a 350-meter hill under normal Earth's gravity's acceleration. Okay, we talked about this, 9.8 meters per second squared. How much potential energy does the roller coaster have? So we've got mass. Mass is 1,000 kilograms. So let's go ahead and put that here. We've got gravity, which is 9.8 meters per second. That's also acceleration. And we've got the height is 370 meters. So what we're looking for is the potential energy. You guys can write it EP or you can write it PE. I don't mind. I write it PE actually most of the time. And I want you to remember that potential energy's formula is the mass times the acceleration of gravity times the height. So all you have to do is plug these in. You've got 1,000 kilograms times 9.8 meters per second squared times 370 meters. So all we're going to do is type that into our calculator, 1,000 times 9.8 times 370, and you will get 3,626,000. What are our units going to be if we're talking about energy? Remember, energy and work is the exact same units. So we're going to have 3,626,000 joules. All right. Next one, imagine that the same roller coaster has been built on the moon. So this number is going to be different. It still has a mass of 1,000 kilograms and is at the top of a 0.75 kilometer, 0.37 kilometer hill. If the potential energy of the coaster is 700,000 joules, 700,000 joules. What is the acceleration? So we're trying to find what the gravity is there. Remember how I said in the first worksheet how this is the reason why your weight is different on the moon than it is on Earth. It's all because of gravity. Your mass is the same, but gravity's acceleration is different. One important thing is when we're doing height, the SI unit for height is going to be in meters. So we need to convert this, okay? This is the same thing, kilometers to meters. It's going to have 3 hops to the right. So take this, 1, 2, 3. This is the exact same thing as saying 370 meters. So we know that the formula for potential energy is mass times gravity times height, okay? But we don't have gravity this time. We do have potential energy. So the way I would do this is to plug and chug it, okay? You've got 700,000 joules. Sorry, I forgot a 0 over there. And that equals the mass, which is 1,000 kilograms, times some unknown gravity, times 370, okay? So what I would do first is I would combine these two numbers. We can't solve for G yet, but we can do 1,000 times 370. So what you can do is you can do 1,000 times 370. And what you have then is 700,000 joules of potential energy is equal to 370,000 times gravity, okay? Now what you need to do is you can solve for G. So what I would do is I would divide by 370,000 on either side. This side is going to cancel out. You'll be left with G. And then all you need to do is solve for this side. So 700,000 divided by 370,000. And you are left with 1.89. So that's what G equals. But when I'm talking about gravity, what are the units that we put that in? What are the units for acceleration? Meters per second squared. So G is equal to 1.89 meters per second squared. All right, let's go ahead and go on to our first kinetic energy problem as a class. So back on Earth, the roller coaster reaches a final speed of 85.15 meters per second at the bottom of the hill and still has a mass of 1,000 kilograms. How much kinetic energy does the roller coaster have? So we don't know what the kinetic energy is, but we do know that the mass is 1,000 kilograms, and we know the velocity or the speed is 85.15 meters per second. So we know that kinetic energy is equal to 1/2 mass times velocity squared. You really, really, really need to be careful about this square because a lot of people applied this cube to this square to every single variable. This only is attached to this b, okay? So what I would recommend doing is almost writing it out like this. We don't know what the kinetic energy is, but we do know that we have 1/2, we have a mass of 1,000 kilograms, and we have a velocity of 85.15. This is what's being squared. So I would recommend drawing that out just like you have it inside the parentheses. So all you're going to do is type this in, 1/2 times 1,000 times 85.15 squared. Notice how I put that in parentheses. Everything needs to be in parentheses because otherwise your order of operations may be messed up and then your final answer will be incorrect. So when you multiply all these together, you will get a kinetic energy of 3,625,261.25. So 3,625,261.25. What are the units for energy? Joules. All right, let's go ahead and flip over to the next page. I'm not requiring that you did this one. I am going to do one of these problems. I'll go ahead and do number 2 with you. A baseball has been thrown 0.15 kilometers into the air under normal Earth's gravity of 9.8 meters per second squared. That's like the acceleration. If the baseball has 55 joules of potential energy, what is the mass of the baseball? So we do not know what the mass is, but we do know that the potential energy is 55 joules. We also know that gravity is normal, Earth's gravity, so 9.8 meters per second squared, and the height is 0.15 kilometers. The formula for this is potential energy is equal to mass times gravity times height. So all you need to do is we have potential energy, so 55 is equal to the mass, which we don't know, so I would just put mass, gravity, which is 9.8, and then height, which is 150. The reason why I have 150 is, see, this is in kilometers. We need it in meters. So kilometers to meters, that would give us 150 meters. Okay. Now what you're going to do is I would combine like terms. You've got 9.8 times 150. That gives you 1,470. But we still have m. Okay. This side has not changed. How can I get this number over here without disturbing m? Because it's multiplied, we have to do the opposite. So we're going to divide by 1,470, divide by 1,470. These will cancel out. 55 divided by 1,470 will give you 0.037, and I'm looking for the mass. What is our mass always in? Kilograms. All right, we can do one on each of these pages. Let's go ahead and do this one down here. A roller coaster reaches the final speed, or the velocity, of 15 meters per second. So let's go ahead and write down 15 meters per second for velocity. At the bottom of a hill and has a mass of 2,000 kilograms. So 2,000 kilograms. What is the kinetic energy? So all we have to do here is we do kinetic energy is equal to 1/2 times mass times velocity squared. We do not know the kinetic energy, but we do know that we multiply 1/2 times the mass, which is 2,000, times 15 squared. Remember, we are not squaring every single variable. So another way you can do it is this. You could do 0.5 times 2,000, and you were to get 1,000. And then you could do 15 squared, which is 225. 1,000 times 225 gives you 225,000. What are the units for energy? Joules. So 225,000 joules would be the correct answer. Okay, one last problem on this page. And guys, if you would like for me to go over any more of these with you, you're more than welcome to email me or come in and talk, and I can go through some of them with you. All right, the last one I'm going to do is number 7. This can be tricky for some people, so let's go ahead and go through it together. Jake is trying to roll his car uphill without using a gas pedal. It will require 28,000 joules of energy to get all the way to the top. So let's go ahead and write the kinetic energy is 28,000 joules. If his car has a mass of 5,000 kilograms, how fast will he have to be driving to get his foot off the gas? So it's asking for the velocity. Now, the formula we're looking at is going to be kinetic energy is equal to 1/2 times mass times velocity squared. And this is where people are going to get frustrated. We do not know the velocity. And notice how the velocity is what's squared here. So we have to just plug it into this equation. We know that kinetic energy is equal to 28,000. We have 1/2. We know that the mass is 5,000 kilograms. But the velocity we don't know, and that's still squared. So what we're going to first do is multiply 1/2 by 5,000. And 1/2 of 5,000 gives you 2,500. And we still have our velocity squared. We also still have our 28,000 joules on this side of kinetic energy. I want to separate this from this, okay? We need to get our like terms on each side. So we're going to take this, and because these are multiplied, we can divide it to cancel it out. So 2,500 divided by 2,500, 28,000 divided by 2,500. Now, on this side, you'll be left with v squared, and on this side, you'll be left with 11.2. Guys, whenever you have something that's squared, in order to get just the letter by itself, you're going to have to find the root of it. You're going to have to find the base of it. And the way you get rid of a square is you square root it. So we're going to square root this side, but you have to do it to the other side, so square root this side. When you square root something that's already squared, you're just going to get the base of it, so it's going to be just v. When you square root 11.2, you will get 3.34. So your final answer is going to be 3.34, but how do we measure velocity or speed? Meters per second. If you're confused on this, come on in and see me. Thanks, guys.